Emma, I've just realised that I actually might need you around the YouTube chat. Is that okay?
Ah, yeah, no, that's fine. I'll have it on in the background. So,
All right.
yeah, don't
If you
worry.
don't see it though and saw what's here, that's fine. I can just
Yeah,
talk.
I'll just keep an eye on the chat and I'll let you know if anything comes up.
All right, thanks. That's brilliant. Okay, so it's just turned 1:30 now, so let's get started. Hi everyone who is watching on YouTube Live. My name is Louise Caitner and I'm part of the Computational Social Science training team at the UK Data Service. And I'm going to be running today's Code Anxiety course. I'm also joined by Emma Green and she's going to be facilitating and manning the YouTube live stream chat. Uh, So yeah, before we get started, just a few points to note about interaction. So we're currently live streaming to YouTube and these sessions are supposed to be interactive. They're a good opportunity for you to post any of your questions about the content that we cover. So if you would like to get involved, then make sure that you've signed into your YouTube account and you can post some comments which Emma can read out during the session. I'll then respond to any of the comments or questions that you have and help you out on any of the areas that you might be struggling with. But yeah, please do bear in mind that there will be a slight delay in the live stream of about 30 seconds. So if you think, oh, I've asked the question and I've not got around to it, don't worry, I probably will do, but it'll be about 30 seconds from when you've asked it. And yeah, finally, just a little bit of quick advertising for our next Code Anxiety session, which will be covering naming conventions and why it's important to be consistent with it. So we'll be showing you how to structure a directory so that the folders and files are associated with your projects are all in the right place. And finally, we'll demonstrate how you can set your directory, which is crucial for any programmer, as it's going to determine where your scripts are run, where files are accessed, and where the changes are made. So yeah, if you want any more information about any of the other upcoming sessions, please do be sure to check out our UKDS events page. Okay, so for today's topic, what we're going to be covering today are the ins and outs of installing coding software and coding libraries or packages. Technically, there is a little bit of a subtle difference between libraries and packages, but for now, we're not going to worry too much about that, and we're going to sort of use that term interchangeably. So I guess let's just crack on and get started. So the first thing that we'll start with is where all coders start, which is by choosing our programming language. So for those of you that have watched our sessions in 2024, you might remember that we covered the differences between both languages and why you might want to pick one over the other. But if you still don't have an idea of which one will work best for you, or you didn't join those last sessions, then I will advise you for today's session to just go ahead and pick one and try it out for yourself. But I suppose I can say that if you've used SPSS or Stata before, you will probably find R quite intuitive. It's generally more user-friendly, and it does feel like a natural step up from those traditional statistical software packages into coding. Python, on the other hand, is a bit more flexible and powerful in the long run, and it's a great choice if you're interested in a range of things. So it's good for data science, automation, or just integrating your work with other technologies. So I suppose it's good to bear that in mind. So to install the latest version of Python, it's quite easy. What you're going to want to do is you're going to want to head to the official website and make sure that you pick the right version depending on whether you're using a Windows or Mac operating system. If you've decided to go with R instead, what you want to do is head to the official R website, sorry, and you'll see that it'll take you to a page titled CRAN Mirrors. It stands for Comprehensive R Archive Network, and you can think of it as a big warehouse that stores R and R packages, where you select the mirror. So you can think of that as the copy of the warehouse that's closest to you. So for me, I'd scroll down to the UK, and I'd probably pick Imperial College London and click that link, then select the right download for my operating system. So I suppose a good thing to do is I can demonstrate where you want to go. Let's see. I'll have to switch around my screens a little bit, but shouldn't take too long. So let's get this Python one up, and let's have a look at R as well. Okay, and let's also, right, I'll share my screen again. So yeah, if you're hopefully you're seeing this screen here. So you want to get the latest version. So bear in mind as well that each operating system is different. So if you're working with Windows, you're going to want to click Windows. If you're working with Mac, which is recognized that I am, you would just go ahead and click this link. So let's say we were going to do the latest. Does this have the file here? Let's just go back and let's just go and click this. So yeah, what you'll get is a installation package, and it'll bring up this. I'm not sure if you can see it. I'd have to share my whole screen, but it'll bring up the installation wizard, which is just the little box that's going to take you through how to install it. It's all very easy. Just keep going until it's installed, and then we can use some commands to check where it's installed. So I'll show you. So this is the page that you'll need if you're going to download R. So this is what I was talking about before, are these mirrors. So like I said, it's just a copy of the warehouse that's closest to you. Think of it like that. So I would go down to the UK, and like I said, you can pick whichever one you want. So I've just picked Imperial College London. But yeah, depending on where you are, you're going to want to click into that, and then again, make sure you're downloading the right one for your operating system. So I would be downloading this for Mac, and then again, you're going to want to check, okay, well, what chip do I have? So do I have an M1 or M2, or do I have a older Intel chip? So you can find that out on Mac, and then you just click that. Same thing is going to happen. It's going to come up with that, what you call it, install wizard. Just go through, follow the steps, and then you'll be set. So let's now switch back. And that I could have just stayed on that. Oh well. Okay. So yeah. Right. So yeah, once you've installed and everything, and you've done the import wizard, that'll take you through the necessary steps. If there is anyone that's following along and you are downloading now, you can just give me a shout if there's any issues, as I know that sometimes depending on the OS, there can be some additional hurdles. Then what you're going to need to do if you're using Python is make sure that you install a coding editor or an IDE. So for those starting out with Python, I usually recommend VS Studio Code. It's quite user friendly and it's got like a load of features that are quite useful if you're early in your coding journey. We did talk about coding editors and IDEs in the last batch of Code Anxiety sessions, but for those who don't know, they're basically the programs that you write and run your code in. However, if you're an R user, it's actually quite nice because you don't have to go searching for the perfect IDE as you have RStudio, which is set up for R users. So you can see here, this always gets in the way. So you have to install RStudio as well. And again, make sure you're picking the correct operating system. So what you can do, sorry, give me 2 seconds. So yeah, when you're installing stuff, it's always good to know where it lives in your file system. And as we're getting used to using our command line, it's good to sort of like confirm where it lives. So what you can do is I've put the commands in this table here for you to check the file pathway for your newly installed programming language. And there might also be times when you need to check the version of Python or R that you have installed. And to do that, whether you're using Mac, the terminal, or Windows PowerShell, you can simply type -3 followed by a couple of dashes and then version, and that'll tell you where. So I can do that now. We'll stop sharing and I can share the terminal and we can just confirm that we've got everything where it needs to be. So I'm just going to share my desktop. Let's go ahead and zoom in a bit here. So I'm on a Mac operating system, so that's going to determine which command I use. So I'm going to do which -3. See, it's telling me where it lives. So it's within my library folder, within frameworks, and then it specifies the version as well. But like I said, another way that you can check the version is if you just type -3, followed by a couple of dashes, then version, that's going to tell you the specific version that you're working with, and that can be quite useful. So let's move on to the next thing. So what we're going to talk about now is coding packages. So simply put, coding packages are collections of code and resources that are bundled together to build upon what you can do with programming languages, sorry. So they're extremely useful because they're going to save you a lot of time and effort. So instead of writing everything from scratch, what you can do is you can use functions from existing packages to achieve the goals that you've set yourself. So we will talk about functions a bit more in another session, but for now, just think of them as reusable bits of code that do a specific job. You just give them some input, they run a set of instructions, and they give you an output. So for instance, maybe you want to apply some machine learning algorithms to a data set, but you don't want to have to build the whole algorithm from scratch, right? That's super intense. It's going to take a lot of time and it's going to be very maths intensive as well. And if, like me, you're not very good at maths, that's going to be really, really difficult. So what you can do instead is you can import a package such as, I've got some examples here. So these white ones are Python packages, and I've just put the R ones in black just so we can distinguish. So yeah, maybe you want to do some machine learning. You can import a package such as scikit-learn in Python or caret in R, where you can get these functions that are going to be able to implement a lot of these popular algorithms. And luckily for us, there is a package for just about everything. So again, maybe you want to create some visualizations, but we don't want to have to create the chart from scratch because that's going to be, again, it's going to require a lot of knowledge and it's going to take a long time. So what you can do instead is you can just grab a visualization package like matplotlib here for Python, or ggplot2 for R. Another way to think of packages are as sort of like pre-made meal kits. So they come with the recipes and the ingredients that you need, which allows you then to focus on creating something great without having to sort of faff about with all the prep. Another way we can think about them is as apps. So our phone comes with basic things, right? So we can call and we can text, but we install apps to add extra functionality to our phones that can do more exciting things. And I can show you that a bit now. So what I'll do is I'll just stop sharing. I'll get up what I need to get up. Let's see. Let's go to documents. Let's go to that. Let's go here. See what's in there. Okay. So I'm going to show you a little example of what I mean about packages. But for now, let's make sure that's right. So what I've got here is I'm in a coding editor in Python, and I'm just going to show you what packages really are to sort of like bring it home. So with each programming language, Python, R, I'm trying to think of other programming languages, C++, whatever, you'll get built-in functions. Okay, so a built-in function here could be a print statement, right? So what I should have done is put the output there. So we have a print statement, right? So we can run this and it'll output hello. So that's a function there that is built into Python. We have another thing here. So I've just created a variable. It's called eg_string, for example, string. And another built-in function that we have is type. So that'll just tell me the data type here. And it says, yep, that's a string. And a string just basically means text. That's how code labels it as a string. So what are package functions? Well, what I've got here is I've got a package that if you are an aspiring Python coder, you'll become very familiar with. It's called pandas. And to use a package, we have to import it. So I've just imported it and I've given it a short name so that I don't have to type out pandas each time I use a function. So what you want to do is you want to run that. And you can see that it comes with functions, right? So I've got pd dot here, read_CSV, which is just a function that allows me to read in a spreadsheet. And I've got another function that pandas has built in, which I can use on a pandas object, which will print out the first 5 rows. So you can see that's the use of packages. They contain really useful functions that allow us to do certain things, and that's allowed me to read in a data set. Got a ton of functions that allow me to manipulate that data frame however I want, but hopefully that sort of solidifies what we mean by coding packages. Okay, so moving on to our next thing. So we've done packages. So let's talk about package managers. So now that you know what a package is, it's about time we introduced a new term, which is dependency. So a package becomes a dependency when you download it to your machine and refer to it in your project. So if you've got a coding package that you're using for a certain project, so your project depends on it, then it's a dependency. And what a package manager will help you do is manage your project's dependencies. So the package manager often connects to some repository of packages, and what you can do is you can tell it to download a package based on the package name, and it'll download it to your PC so that you can use it. So you can think of it in some ways as an app store for the packages that you want to download. So you saw before I had this package here that I imported, right? Pandas. So before I was even able to import it, I had to download it to my machine, and that's where a package manager comes in. A good thing about package managers is that you can also use them to update your packages or use it to download a different version of the same package for different projects. And when you get familiar with coding, you'll start to realize as well, unfortunately, that dependencies can get complicated fast. So for instance, let's say we're doing some data visualization in Python and we decide to install a package called Seaborn. Now, behind the scenes, Seaborn will pull in a version of another package that it depends on. So that could be Pandas 1.5, because that's the version that it knows how to talk to. But a week later, you could be working on a new web scraping project and you hear that there's some shiny new features in Pandas 2.2, so you want to use your package manager to upgrade it. However, that's all well and good, but then when you go back to your visualization project and you try to import Seaborn, you're going to get an error because it only works with Pandas 1.5. And that's where your package manager is going to come in, and it's going to help you spot that mismatch and then roll it back. So what you could do is you could use a package manager like pip for Python to roll back to a previous version of Pandas. So the same thing could happen as well in R. So you upgrade a package too far and all the package that relies on it then breaks. So yeah, it's important to note that we use package managers to download our packages, but they're not just for first time installs. It's also a sort of referee that keeps your packages playing nicely together. So let's have a little bit of a look at what package managers we're going to be using for our different languages. So in terms of where to start, you can see that for Python and R, we'll be using the default package managers for now. So that's pip if you're using Python, and we're just going to be using the install.packages command in R. And for some of you that are watching that might be a little bit more code savvy, you might know that there's a bunch of different software out there that you can use, package managers. So you might have heard of Anaconda. I can't really think of any off the top of my head for R. But what we're going to do, apparently there's something called Pack for R. But what we're going to do now is we're going to stick with the basics. That's because these are really good for simple tasks that you'll be carrying out as beginner programmers. So, you know, we don't need to get too sophisticated yet. So yeah, what we're going to do is we're going to do a little practice exercise. So you can follow along on the left if, like me, you're using Python. But if you're using R on the right, you can follow along that example. And we're just going to practice installing a package and using a bit of code from it. So let me switch back to just my main desktop. Let's get a new terminal up. Let's zoom in a little bit. Okay. So what we're going to do is we're going to install a package called Rich. I think this allows us to do different things with fonts and colors and stuff. So you can see I've already installed it before, so it's very, very quick for me. It's just telling me you've already got it, here's where it lives. If you're installing this for the first time, it's gonna might take like a few seconds, maybe 30 seconds, and it'll tell you what it's downloading and then where it lives. So then we're going to run this Python free command, and that's going to start a Python session within terminal. So throughout these sort of tutorials and stuff, I've been telling you that it's good to use coding editors and IDEs. It's the place you should be coding, but it's also good to know that you can run Python in your terminal. And there's certain cases when you're going to want to do that to run certain scripts and programs and automate things. So I thought it might be good just to show you this. So what we're going to do is we're going to run these following commands. All green. So hopefully this should just print success, but in green. So yeah, that's an example of us using pip to install a package and then using some of that stuff inside the package. So what we can do is we want to exit out of that. We'll just do quit. And we can just clear that. If you're using Mac, a good keyboard shortcut to know is Command and K, and that'll just clear your console. Okay, so let's go back. Oh, got a question here. I'm interested in Python, but it was recommended to me to install Anaconda. What is the difference? Do I need to install Python to install Anaconda, or will one do? So, that's a very good question. I don't think one will do. I think you have to install Python and then Anaconda. From what I'm aware, I think Anaconda is more of a package manager, but let me just have a look at that because it's been a while since I've used that. Anaconda.
Louise, I think Thorwat has put a little bit of information in the chat about that.
Oh, okay, cool. Thanks a lot. Appreciate that. Yeah, she's probably answered it better than I could, but from my understanding anyway, it's more of a package manager, I think. I'll have a look and see what sort of put. Well, actually, that would involve me going to the YouTube. Yeah, maybe if we get another question on that, I can do a bit more digging. But if Salwat's answered it completely, I'll just I'll crack on for now. But yeah, I'm actually going to talk a little bit about Anaconda when we get to package managers later. And I'm going to show you the way that I sort of like, no, sorry, when we talk about virtual environments, I'm going to talk about how I set up my virtual environments because I did used to use Conda and I actually found it a bit complicated and it got a bit too messy. So I uninstalled it and now I just use a different method that I find simple. But Anaconda is also pretty good according to a lot of people. So let's go back. Right, so let's talk a bit about now virtual environments, which is what I just mentioned. So now that we know what packages and dependencies are, and we've also introduced package managers that can be used to, install, upgrade, or roll them back. Let's talk a little bit about that problem that I mentioned when we have clashing dependencies. So I asked you before to imagine that you were working on a Python project on visualizations that involved that Seaborn library, which only works with Pandas 1.5. But then you start a new web scraping project and you decide that Pandas 2.2 looks pretty good because it has loads of new features and you want to upgrade it. However, of course, that means when you go back to your visualization project and import Seaborn, there's going to be an error. So you roll it back to 1.5 and that might be an okay fix for now, but let's imagine that you're working on 3 projects simultaneously or that over time you've built up to 10 projects. That's a hell of a lot of packages. And the potential then for these dependency clashes is going to increase. And that's where virtual environments come in. So If we think of packages, like I said, as those pre-made meal kits, we can kind of think of virtual environments as kitchens to sort of house these meal kits in for different projects. For instance, if I created a virtual environment and gave it a name like visualization stuff, what we can do is we can group packages together in their own separate environments so that we avoid any dependency clashes. Then we can do the same thing for my web scraping projects and then group those packages together in their own virtual environment. And there are many advantages to doing this. Of course, obviously the main one is that we create a private sandbox for each project, which is going to prevent those clashes. But also, as you get more confident as coders, you might want to shout about your work, which means that you might want to share our code online. I mean, your code online. And later we're going to be talking a bit about how you can do that with software like Git. But to make sure that your code is reproducible, what's quite good about having a virtual environment is that you can simply freeze that environment into a snapshot file, which then becomes a sort of shopping list for every package because it lists every single package and its exact version so that anyone who then downloads the projects, what they can do is then point their own package manager at that list and then rebuild that same sandbox in one click. So we're going to go on to a little practice exercise to show you how to build a little virtual environment. But before we do that, I'm going to show you a few of my environments to sort of show you how they work and what they've got in them. So we're back on my desktop and I've got a dedicated folder that I call virtual environments. So I'm going to use ls to list what's in there. So you can see that some of these names are quite intuitive, right? So I've got ML, and these are my general purpose sort of ones. So ML here has a bunch of packages related to machine learning. SNA, that's social network analysis. So I've got a load of packages that are related to that. Then I've got web_scrape, which is going to be all my web scraping stuff in there. And I've got int_viz, which is for my interactive visualization packages, all the stuff that I need in there to do that stuff. And then I have also some specific projects which are a bit more targeted. So I have this UCRI one here, which is when I was doing working on an UCRI project. So I'll have all my relevant sort of packages in there. I've got this other one, which I think was for some coding quiz competition thing, and then OpenAI, which I think was when I was using ChatGPT's API for something. So you can really make them dependent on your project. It's good sometimes to think carefully because these can take up a lot of memory. So you might want to have some general purpose ones like I do, like a machine learning one, maybe a data science one that just has, I don't know, pandas and a couple of other packages that you might need to do some quick sort of data science and analysis. But you can get as specific as you want. So the way that we activate these, so what happens is before we start coding, we'll want to activate this, and then we're going to type in, then you can open your coding editor like what you call it, Virtual Studio Code or Visual Studio, whatever it's called, or Jupyter Notebook. But before that we do that, we want to work in a specific environment. So let's say I want to work in this machine learning environment. I'm going to go source, and then I'm going to give it the pathway to the activation script. So it's machine learning. We go to the bin, then we go to activate. And you'll know you're in a virtual environment because you'll see that you've got the brackets here that should have appeared next to your the name of your PC. And you can see that it's got the correct name in it. So I'm active in this environment now. And I can show you some of the packages that I've got in here by simply doing pip then list. So you can see just the sheer amount. So this is just for machine learning, but we've got a hell of a lot of packages in here because all of the packages that you download. So I might have only asked Pip to download 4 or 5 packages, but they all come with other inbuilt packages, right? So it gets like I said, the potential for it to get messy. Imagine if you didn't have these virtual environments and you were just, using pip to upgrade this package and downgrade that package. It would be an absolute nightmare. So this is why it's good to use these virtual environments. So yeah, we can have a look at another. So if you want to deactivate, we just simply type deactivate. We could do source. Let's go into my social network stuff. Then activate. And if we do pip list again, we'll see a bunch of different packages and all of their versions. Okay. So these are what virtual environments are. If I then wanted to, I could go to a specific project folder. So I could go on let's go to that one that we were in before. So that one where I showed you that test script. So we could go into this. Then if I typed in a coding editor like Jupyter Notebook, what that's going to do is it's going to open that coding editor and I can code within this virtual environment. So let's go back. We're a little bit over time, but you can stick around, I guess, for a few more minutes if you'd like to. If you have somewhere else to be, no worries. Yeah, so what have we got here? So this is the last thing that we're going to do. If you're in R, you can follow along on the right. Bear in mind, if you are going to be doing this in R, you're going to need to use install.packages with RENV, and that's going to basically put RENV into your global R library so that that command rn init is going to work. But for the Python one, I suppose we can just go through it now. Okay, so sorry about all the faffing around. Okay, so let's do Command and K, because that's how we clear everything. Should I deactivate? Okay, let's go back to home. Let's just clear that. Right. So what we're going to do now is we're going to create a virtual environment. So a good practice for you is to create a folder where these environments live. Otherwise, I'll just go into your root folder, which might be fine, but I like to have mine all tucked away neatly so I can find them all together. So bear that in mind. But for now, we'll just create it in the root folder. So what we're going to do is we're going to use this Python free command followed by a dash and then m, and we're going to use VNV because that's what creates our instance of a virtual environment. And then we'll give it the name my test environment. So we've done that. If you use ls, what you can do is you can see my hideous root folder, but you can also see that we should have my test environment. And you can tell I've done this before because I've got one that's called my new environment. So yeah, now that we've got that, what we can do is we can activate it. So remember, we use source, then we follow it with the name of the environment. If you created it so that it lives in a folder, you'll put the folder name first and then the name of it. So make sure you get the pathway right. So we've got my test environment, then we've got bin, then we've got activate. And has it worked? Yes, because we can see that we've got the name of it here before the name of RPC. So what we can do now is we can do pip list, see what packages are in there. And of course, there are no packages apart from pip and setup tools because we've not installed anything yet. Then we're not going to install anything just now. We'll just do deactivate and we'll leave it there for today. Is there any questions in the YouTube chat or anything that anyone wants to ask and I can get round to them? We can have a few more minutes if needed.
No more questions, Louise.
Cool. Okay. Well, In that case, I think I'm probably going to leave it there. And if there was anyone watching and you would like to come to the next one, you can have a look at our events page. It's going to be on the 11th of November, and we'll be looking at the best practices for coding projects. But thanks, and that's it.